Dear students, let us see what are the do's and don'ts while solving the trigonometric equation. The first thing is don't squaring on both sides. Don't do that. So unless otherwise, if it is a necessary only, then only you have to square. But while squaring that, you should be very careful. Okay. Don't squaring on both sides, cubing on both sides, taking whole power 4 on both sides. You should be avoided as far as possible. Why? Let me check one example. Let me show you one example. For example, sine theta is equal to 1. Sine theta is equal to 1 means sine theta is equal to sine pi by 2. Sine theta is equal to sine pi by 2. Then your theta is equal to n pi plus minus 1 whole power n into alpha. So what are the solutions you will have? If you observe the solutions, theta is equal to, so if you draw the graph, you can easily understand this solution set. So this is equal to, so 0, so it's a x-axis, this is a pi by 2, this is a pi, this is a 2 pi, 3 pi by 2, this is a 2 pi, and this is a 5 pi by 2. This side minus pi by 2, this is minus pi, minus 3 pi by 2, minus 2 pi. So this is 1, so sine 0 pi by 2, again 3 pi by 2, again 2 pi, again 5 pi by 2. Okay now, so this is the graph you will have. Okay now, right. So this is the graph of y is equal to sine theta. Now what is the graph of y is equal to 1? So y is equal to 1 is a line parallel to x-axis. Okay, observe what are the solutions here. What you will get? So therefore your theta is equal to pi by 2. Theta is equal to pi by 2. Next solution is 5 pi by 2. If we come to the negative side, it is minus 3 pi by 2, minus 3 pi by 2. So on you will get the solutions. Okay now. If the same problem is squaring on both sides, if you do the squaring on both sides, let us see what happens. For example, sine theta is equal to 1. This is sine square theta is equal to sine square pi by 2. Sine square theta is equal to sine square pi by 2. So we have the general solution theta is equal to n pi plus or minus pi by 2. N pi plus or minus pi by 2. So let us take n is equal to 1. Check what happens. N is equal to 1 and take the plus. Then theta is equal to what happens? You see here pi plus pi by 2, 3 pi by 2, one of the solution you are getting. Pi plus pi by 2, 3 pi by 2. If you take minus, pi minus pi by 2, pi minus pi by 2 is equal to theta is equal to minus pi by 2, you are getting solution. If you observe the graph, at theta is equal to 3 pi by 2, these two are not intersecting. At the same time, for minus pi by 2 also, this curve and the tangent both are not touching. Understand? So this is happened only because of your squaring on both sides. Understand? So as far as possible, don't square the graph. Don't square the given equations. Okay? Don't squaring on both sides. Okay? If it is possible, then you have to define the domain, everything. Okay? So I hope that you understand this concept. Okay? At the same time, don't cubing on both sides also. Okay? So next precaution. So dear students, let us take the second important things. Second one is never cancel the terms. Never cancel the terms. In general, while solving the equations in algebra, generally we will cancel the terms like that. But here you should not cancel the trigonometric terms on both sides. For example, if you get, for example, sine square theta minus sine theta is equal to tan theta. Generally, students, what they will do now, sine square theta minus sine theta is equal to sine theta by cos theta. Therefore, here also sine theta is there, sine theta is there, sine theta is there. We can take common outside and they can cancel. That means dividing with sine theta. This is equal to sine theta minus 1. This is sine theta by cos theta. This is 1 by cos theta. And take their common, like that they will do. But you should not do this type of things. Understand why? Because if you take cancelled sine theta, so that means for sine theta is equal to 0 also, one of the some solutions you will lose. So you have to take sine theta common outside, then sine theta will become 0, then theta is equal to n pi. You will lose this type of solution. Theta is equal to n pi, all solutions you will lose. Okay. So don't cancel the terms. At the next precaution what you is, don't divide the terms which are equal to 0, For example, if the same problem is there, if don't divide with by sine theta, by sine theta, by sine theta. For example, if it is given theta belongs to 0 to pi, if it is given, then if it is given, if you divide with sine theta, then what is sine 0? Sine 0 is 0. So you should not divide with 0. You should not divide with 0. Understand? So this is the third precaution what you have to take. Okay. So the first thing is, so here never cancel the term, never divide the term which are equal to 0, which are equal to 0. Okay. Don't do that. Okay. The next thing is, so dear students, the next precaution what you have to do is, whatever may be the final answers what you are getting, that should be defined. For example, if you get one equation is there, for example, tan theta minus secant square theta is equal to 5. So this is a one type of trigonometric equation. So you have to solve it. Okay. So at the end, if you get theta is equal to some values pi by 2, something. So be careful about these values. So what are the values you got? Whatever may be the values you got, check whether those values are valid or not. For example, if you take theta is equal to pi by 2. So what is tan pi by 2? Tan pi by 2 is not defined. Okay. So whatever may be the solutions you are getting, all solutions, some solutions are valid and some solutions are not valid. So this should be the precaution you should take. That means what is the precaution? After getting the solutions, you should once check whether those solutions are valid or not. Okay now. So next precaution what you have to do is, don't change the domain. So for all trigonometric equations in general, they will define the domain. For example, what? So x belongs to minus pi by 2 to plus pi by 2. Otherwise, theta belongs to some 0 to 2 pi. Like that, they will define the terms, but don't change these domains. Don't change the domains. You have to find out the solutions which belongs to these domains. Okay, na? So these are the main basic precautions. You have to keep it in mind while solving the trigonometric equations. Okay, now I am going to explain a few problems in this trigonometric equation using graphs. If you have the knowledge of drawing the graphs of trigonometric functions, solving trigonometric equations is a very easy, and it is also time saving process. Okay. So let us see that graphs. Dear students, see, one question is, the number of solutions of modulus of cos x is equal to sin x, 0 less than or equal to x less than or equal to 4 pi r. So the number of solutions. Understand? So here options are also given. Generally, students, how they approach is, modulus of cos x is equal to sin x means, therefore cos x is equal to plus or minus sin x. They start doing cos x is equal to plus or minus sin x, and they start doing. So first take case 1, take plus cos sin x, and they will take case 2 minus sin x. They will solve the problems, and the solutions which belongs to 0 to 4 pi, those are the solutions. It takes a lot of time. So if you know the solving these problem using graphs, that means draw the graphs of y is equal to mod cos x, y is equal to sin x. The problem will be very easy, very easy. Okay, within 1 minute you can solve this problem. Okay, let me show this. First graph is x-axis and this line is, so here I will take the line, so this is a y-axis. So x-axis, y-axis. Now our interval is from 0 to 4 pi. Yes, let us take those 0 to 4 pi values. So this is 0, this is pi by 2, this is a pi, so this is a 3 pi by 2, this is a 2 pi, this is 5 pi by 2. So this is a 3 pi and it is a 7 pi by 2, and the last it is 4 pi. So this is pi, 2 pi, 3 pi, 4 pi, pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2, right? So the maximum value is 1 and the minimum value is -1, right? So first I will draw the graph of sin x. Sin x graph is very easy. First I will draw the graph of sin x. So sin 0 is 0, pi by 2, pi, 3 pi by 2, 2 pi, again 5 pi by 2, 3 pi, 7 pi by 2, 4 pi, like that it will go. Okay, so this is the graph of, very easy, anybody can draw it. Okay, now what is the graph of cos x? What is the graph of cos x? Right, cos 0 is 0, right? Again cos pi by 2, cos pi, 3 pi by 2, 5 pi by 2, 7 pi by 2, 4 pi, like this. But it is y is equal to modulus of cos x. Modulus of cos x means what? Whatever may be the graph lies below the x-axis, its reflection you have to take, its image you have to take. That means here minus plus pi by 2 to 3 pi by 2, it comes down. It comes down of the x-axis. Then you have to take the image. Then you rub it. Understand this? Again, here 5 pi by 2 to 7 pi by 2. Again it is come down. Take the image. So this is equal to y is equal to modulus of cos x. Y is equal to modulus of cos x. See here. So black is y is equal to sin x, whereas blue is y is equal to mod cos x. First, to draw the graph of cos x. Whatever may be the lies below the x-axis, you take the image of that. Now, observe these two graphs and at what points they are intersecting between 0 to pi. From 0 to pi, if you observe, they are intersecting here 1, 2, 3, 4. But here intersecting, but it is beyond 4 pi. So how many points are there? 1, 2, 3, 4. So 4 is your answer. Understand? So very easy. So if you draw the graph of y is equal to sin x, first to draw the graph of y is equal to cos x. Since it is a modulus of cos x, whatever may be the graph lies below the x-axis, just to take the image with respect to x-axis. Understand? So I hope that you understand this solution. So let us go for next problem. Dear students, welcome to the second problem. Here also one more question is there. The number of solutions of cos x is equal to modulus of 1 plus sin x in the interval 0 to 2 pi. So generally immediately the students start, they try to open the modulus. So 1 plus sin x is equal to plus or minus cos x, and they start taking plus cos x and minus cos x, 2 case 1 case 2, and they start doing the problem, and ultimately they will get the answer. But try to solve this problem using graph. Okay, now I am going to solve it. So here take a horizontal number line as x-axis and a vertical number line as y-axis. Okay, right. So 0 to 2 pi, the interval is 0 to 2 pi. So those only I am taking. So 0, so this is pi by 2, this is pi, and this is 3 pi by 2, it is 2 pi, the interval. So this is equal to 1 and it is -1. First I will draw the graph of y is equal to cos x. Right, you know the graph of y is equal to cos x is, so cos 0 is 1, so cos pi by 2. So cos pi by 2 is 0, and this is a 3 pi, and 3 pi by 2 is 0, again 2 pi. So this is the graph of y is equal to cos x graph. So this is y is equal to cos x graph. Now what is the graph of 1 plus sin x, modulus of 1 plus sin x? To draw the graph of y is equal to modulus of sin x, first draw the graph of sin x. Okay, now first draw the graph of sin x. As you know, the graph of sin x is sin 0 is 0 and sin pi by 2 is 1, sin pi is again 0, sin 3 pi by 2 1, sin 2 pi. So I am just dotted line is 3 pi by 2. So this is the graph of y is equal to sin x. What is the graph of y is equal to 1 plus sin x means whatever may be the graph. If it is y is equal to f of x graph, if y is equal to, if you want to draw the f of x is plus a or minus a, whatever may be the graph, it is for example y is equal to f of x, this graph is y is equal to f of x plus a and this is y is equal to f of x minus a. That means if it is a plus a, total graph you raise to a units. If it is a minus a, total graph you made down to a units. So here what is there? Plus 1 is there. So this is called as 2. So this total graph you raise to 1 unit. You raise to 1 unit above. So that means what? So here it is a 0 is there. Then it will start raise it to 1 here. Then again it will come. Here pi by 2 is there. So up to here it will come to here. So this is your, so again here pi is there and it will come to here. Here it will come. Okay, now again 3 pi by 2 is there. 3 pi by 2 up to here it will come. Understand? So it will come 3 pi by 2. Okay, so this is up to here. Again it will come here. Again this is equal to y is equal to 1 plus sin x graph. That means if you observe the graph, dotted lines you observe, it was raised to 1 unit. So here to 1 unit, here 1 unit, here 1 unit. So here to here 1 unit, here to here 1 unit, 1 unit. The graph is raised to 1 unit. Coming to the modulus part. Modulus part, if you observe the total graph, whatever may be this black line, total graph is above the x-axis only. Above the x-axis only. Okay, but y is equal to sin x graph, some parts are below the x-axis, but modulus 1 plus sin x graph is completely above the x-axis. Understand? Now observe that in between 0 to 2 pi, in how many parts it intersects? How many parts it intersects? See here. So it intersects at 1 here and second point and it is third point. 1, 2, 3. Therefore, the number of solutions are 3. Number of solutions are 3. So if you draw the graph, within minutes you can solve this type of problems. Okay, now I hope that you understand the solution. So let us go for next problem. Dear students, welcome to third problem. Find the solution set for modulus of tan x less than or equal to 1 where x belongs to minus pi to plus pi. That means you have to search the values of x from the interval minus pi to plus pi, including minus pi and plus pi, for which modulus of tan x is less than or equal to 1. Okay, now right. So to do this problem, so you draw the graph of y is equal to modulus of tan x and y is equal to 1. The intersecting part will give the answer. Okay, so let me draw the graph. So the horizontal number line is x-axis and it is x-axis and it has a vertical number line, it is y-axis. Okay, now right, from minus pi to plus pi. So we know the values 0. So I will take this as a 0. This is pi by 2. This is pi. So somewhat 3 pi by 2. This side minus pi by 2 minus pi minus 3 pi by 2. Okay, now we know that first of all I am going to draw the graph of tan x, right. So at pi by 2 minus pi by 2, 3 pi by 2, here also plus 3 by 2, here minus 3 by 2. At that point, tan x is not defined. So, what is your graph is, so this is not defined, tan 0 is 0, tan minus pi by 2 is not defined. Tan minus pi by 2 not defined, tan minus pi is 0, not defined. So, this is also tan 3 pi by 2 not defined, tan pi is 0, tan 3 pi by 2 is not defined. Okay, now, so that is the graph of y is equal to tan x. Now, what is the graph of y is equal to modulus of tan x? Now, what I told, whatever may be the graph lies below x-axis, just you take the image. So, here observe here, so from here to 3 pi by 2, it lies below the x-axis, no, just to rub it, take it this is the graph. So, whatever may be the lies below the x-axis, take it is the graph. Whatever may be the lies below the x-axis, take it the graph. So, this is y is equal to modulus of tan x graph. The red line is y is equal to modulus of tan x graph. That means the graph should not lie below the x-axis. Okay, that is over. Now, y is equal to 1, as we know that y is equal to 1 is a line parallel to x-axis, and it is passed. So, this is y is equal to 1, y is equal to 1 line. So, what is the, so and one more thing is given. So, what is the one more given thing? Here less than or equal to is there, less than or equal to. That means the red line and the black line, what are the parts lies below the y is equal to 1 line, that is a less than or equal. That means the tan x graph should be less than or equal to 1, y is equal to 1. So, is it not this part, required part from here to here? This is the required part. Here also here, from here to here, from here to here, from here to here. Of course, here you should take only the up to pi, here only pi you have to take. Observe the graph, up to here only you have to take, from here to here. What are the interval that lies between? So, your answer should be, observe here, minus pi to up to here. The interval is minus pi, including minus pi to pi by 2. Minus pi by 2, here open, here closed, union, minus pi by 2 to plus pi by 2. Minus pi by 2 to plus pi by 2, open bracket, minus pi by 2 to plus pi by 2. This part is also minus pi by 2. Again union, open bracket, minus pi by 2 to closure bracket pi. So, here up to here. So, in these intervals, that means minus pi to open bracket minus pi by 2. Open bracket minus pi by 2 to plus pi by 2. Both are open brackets. Why? At tan theta, the graph is not defined. Okay, the tan theta is not defined. Right. Union again pi by 2 to open bracket pi by 2 to pi. Pi you can take. Why? Because in this interval also pi is there. So, in these intervals, modulus of tan x is less than or equal to 1. So, dear students, so I hope that you understand these concepts today. So, what are the concepts that we explained? So, what we have to do, what we should not do while solving the trigonometric equation. And the second one is using the graphs, how to solve the trigonometric equations. Okay. So, if you know the techniques of drawing the graph, solving the trigonometric equations is very, very easy. Okay. So, I hope that you enjoyed today's class. So, with some more, with a new topic in the tomorrow's class, we will meet. Okay. Now, so until then, goodbye.